I'm hoping that the sound is okay. I just gave it a test. I'm in a coffee shop. No, it is not Starbucks. And we're going to talk today about special products of binomials. There are three types of special products. We have a difference of squares, which we've talked about a little in class so far already. And then there are perfect square trinomials, and those fall into two different categories. We can have perfect square sums or perfect square differences. So we're going to start by taking a look at difference of squares. You may recognize this pattern. If we do a plus b times a minus b, let's see what happens when we FOIL. So I'm going to do the first terms, a squared, the outside terms, so that gives me negative ab, the inside terms, plus ab, and then the last two terms, b times negative b, gives me negative b squared. And notice what happens here. My two middle terms cancel each other out. So I'm left with a squared minus b squared. This is a pattern that you can use anytime you recognize it. So in the problem below, I could say that my a is x and my b is 7. So this product should be x squared minus 7 squared, which is x squared minus 49. You may see examples where your a and your b are a little bit more complicated. So in this case, a is 5x and b is 2. If I apply my pattern, I have the quantity 5x squared minus 2 squared, which means I have to square both the 5 and the x. 25x squared minus 4. The next pattern we're going to look at is perfect squares, and we're going to look at the sums. So notice in this multiplication problem that we have, it's a plus b times a plus b. You may also see this written sometimes as a plus b squared. One of the most common mistakes students make is to say that this equals a squared plus b squared. It doesn't, because we have to FOIL it. If I multiply my first two terms, a times a, I get a squared. I'm going to add my outside terms, ab, my inside terms, ab again, and then my last terms, b times b, is b squared. In this case, my middle terms aren't canceling, but notice they're alike. When I simplify this, I get a squared plus 2ab plus b squared. So let's apply this pattern now to this problem. In this case, again, a is x and b is 7. So I'm going to have x squared plus 2 times x times 7 plus 7 squared. When I simplify, I get x squared plus 14x plus 49. In this next problem, my a is 5x and my b is 2. So again, I'm going to do a squared plus 2a times b plus b squared. And when I simplify, I get 25x squared plus 20x plus 4. The last special product is the perfect square trinomial for differences. If you notice in this example now, it's a minus b times a minus b. So again, this could be written as a minus b squared. When we FOIL it, we get a squared minus ab plus b squared. Again, my two middle terms are alike, so I can combine them. And I get a squared minus 2ab plus b squared. Let's use this pattern on an example now. Which term is a and which term is b? You should identify, in this case, a is x and b is 7. So I'll have x squared minus 2 times x times 7 plus 7 squared. The negative sign in the x minus 7, you might be tempted to say b is negative 7, but that's taken care of in our formula. So you should just take the positive version. So we're going to have x squared minus 14x plus 49. Now I want you to pause the video and try this example on your own. You should have said that a is 5x and b is 2. And then when we plug into our pattern, we have 5x squared minus 2 times a times b plus b squared. So here when we simplify, we get 25x squared minus 20x plus 4. So we're going to be doing some practice with these patterns in class. After we do that, we're going to talk a little bit about Pascal's triangle in preparation for a class next week. And I just want to give you a brief introduction to it. So this is a triangle that counts downwards. We start with a 1, sort of in the top vertex of the triangle. And this triangle has imaginary zeros on either side of that 1. To get line 1 of the triangle, we say, what is 0 plus 1? Well, that's 1. And then what is 1 plus 0? That's also 1. Line 1 also has some imaginary zeros in it. And again, I'm going to add. I'm going to say, what's 0 plus 1? That's 1. Now I'm going to do, what's 1 plus 1? 2. And then I'll do 1 plus 0 is 1. So I'm growing this triangle by adding consecutive numbers together. So if I'm going to go to line 3, I'll have 0 plus 1 is 1. 1 plus 2 is 3. 2 plus 1 is 3. And 1 plus 0 is 1. Take a moment and try to fill out the next 2 lines of this triangle. You should have 1, 4, 6, 4, 1. And then you should have 1, 5, 10, 10, 5, and 1. This triangle can go on forever, and we'll talk a little bit more in class about who Pascal was and why he had this triangle and what makes it useful. But I will give you the hint that we're going to use this in class to expand binomials, things like x plus 3 to the 5th. But again, we're not going to do it until next time, so in the meantime, you should think about how you might use that triangle to help you.